Yeah, I'm sorry, the video was disrupted, so we're back at question number 14. So we're going to have two parts. This is part 2. The decreasing function f has a property that for all real numbers a and b in the domain of f, if a is less than b, then f of a is greater than f of b, and the xy plane, the graph of f is always concave up, of the following which is a positive table of values for f. Now first let's understand the function. The function is decreasing. It could look like this, or it could look like this, right? Let me show you. So it could look like this, or like this one of the two. Now since it's concave up, it's gonna look like the one below, so it's gonna look like this, correct? Now what does this tell us? This tells us basically that the rate is increasing. Remember what I told you? Decreasing function has nothing to do with an increasing or decreasing rate, and that depends on the concavity of the function. Now since the concavity is upwards, that means the rate is increasing. Now let me explain this in actual numbers. So let's say starting at this point, y equals to negative 4x. Oopsie daisy, here we go. So y equals to negative 4x. As we reach to this point, y will be equal to probably 0.5x. Negative 0.5x, let's say. Now, negative 0.5x is definitely greater than negative 4, right? So the rate is increasing. It's turning less negative. At some point, y is going to be equal to 2, let's say. Rate of change will be equal to 0, which is definitely an increase from negative 4 to 0. So we're going to have to look through the answer choices and see which is giving us a rate of change that's increasing. And keep in mind that the function is always decreasing. Now, that means f of x is always decreasing. So from 7 to 2, this function is decreasing, which is correct. We just want to make sure that the slope is decreasing as well. Let's just do that between these 2 points really quick. So 1 and 2. So we have 6 minus 7 divided by 0 minus negative 1, which is negative 1 divided by 1, which is negative 1, correct? Did I mess up? Probably no, I did not. Okay, we're good. Now the second point, 4 minus 6 divided by 1 minus 0, negative 2 over 1, negative 2. Now this is a decreasing rate. It's not an increasing rate. Remember, we need an increasing rate. Negative 1 to negative 2, we're decreasing. So it's decreasing and decreasing. This would actually look like a function. A function would look like this. This would be your function that's decreasing, okay? So concavity downwards basically means decreasing rate. Concavity upwards is increasing rate. It would start at 0, then as it moves downwards, it's going to be decreasing more and more. Okay. So, what's the case? Yeah, it's not option A. Moving on to option B, this function is in fact decreasing, which matches the first criteria. Remember, we're searching for a function that is decreasing and also has an increasing rate since it's concave up. So let's do the math really quick. 5.35 minus 5.05 divided by 2 minus 1. Let me pull this up. I'm not good with decimals. Okay, so we have 5.35 minus 7.05. Okay, so this is negative 1.7. Let's do the second point. 2.65 minus 5.35 divided by 3 minus 2, which is simply 2.65 minus 5.35. So negative 2.7, the rate is decreasing. This one is out as well. What about C? Well, this has an increasing function. It does. The y's are increasing. So that means this is out. And the correct answer is option D. Do we need to test it? Well, not really. But it would look something like this. Let me tell you, it would be like -5, -4, -1, like to 0. That's like an increasing function. So if you want to test it, it's up to you. But yeah, anyways. Moving on to question number 15. The figure shows the graph of a function f. We have the 0 and the extrema for f are labeled. And the point of inflection of the graph of f is labeled as well. Let A, B, C, D, and D represent the x-coordinates at these points. At those points. The following on which interval is f increasing and the graph of f concave down. So increasing concave down, pretty sure this is straightforward. So we have from A to B, it is increasing, and concave down, that's correct. What about B to C? It's decreasing, so that is out. C to D, increasing concave up, not the case. D to E, increasing concave up, which is also not the case. And we want increasing concave down, which is the case with option A. Okay, moving on to the next one. An object travels along a horizontal line with velocity given by the function v. The graph of y equal to v of t, which consists of 4 line segments, is shown. Which of the following intervals is the object's velocity decreasing over the entire interval? Well, from 0 to 4, it is not increasing over the entire interval. It's going to be increasing at some point. And what about 5 to 8? From 5 to 8, it's constant. From 8 to 10, it is decreasing. And that is, in fact, it says 8 to 10 only. You see that? Need to make sure that D is also not true, because from 0 to 3, it is increasing, and this one is also increasing. Let's say they mention just 8 to 10, and they don't say the word only, and this question have been actually flagged, like it would have been correct. Because let's say they just say 8 to 10, and if you mark C, that's correct, and if you also mark D, that's correct. Because they mention which of the following intervals is the object's velocity decreasing over the entire interval. Well, from 8 to 10 is just increasing over the entire interval, which is correct. But since they mentioned the word only, that means they're saying that every other interval is not increasing, right? So it has to be option D, which is the correct answer. Okay, moving on. Question number 17. The depth of water in feet at a certain place in a lake is modeled by the following function. The graph of y equal to w of t is shown, where t is the number of days since the first day of a month. What are all intervals of t on which the depth of water is increasing at a decreasing rate? So what does increasing at a decreasing rate mean? It means the function is increasing, but its concavity is downwards, remember. Concavity that is downwards means that the function is decreasing. Increasing at a decreasing rate. So in this case, we're just searching for this shape. So from 3 to 6, let's look at the first option. Yeah, this is increasing with a decreasing rate, that's it, to be honest. 3 to 12, well, this is decreasing, so that's not correct. 0 to 3, it's increasing at an increasing rate, that's out as well. 0 to 6, out as well. Okay. Moving on to this one. The figure shows the graph of function g for x between 0 and 13. The endpoints of the interval are labeled with points A and E. 2 other extrema for G are labeled with points B and D. Point C is the only point of inflection of the graph of G for the following. Let T of A, T of B, T of C, and T of D, E represent the x-coordinates at those points. Of the following, on which intervals is the rate of change of G decreasing? Remember, when do we have a rate of change that's decreasing? Well, disregard the fact whether the function is increasing or not. Decreasing means concavity is downwards, right? Concave down. Remember this. Let's just look at the parts where the concavity is downwards. This is upwards, not the case. Upwards, not the case. Downwards, the case. Downwards, the case. So it's from TC to TD and TD and E. Yeah, that's it. Option D. Okay. Moving, we have 19 and 20, and that is simply it. With question number 19, the figure shows a container in the shape of a circular cone. The container is being filled with water at a constant rate until the container is completely full. Which of the following could be the graph that models the dependent variable of depth of the water in centimeters as a function of the independent variable of time in hours? So independent T and depth is simply Y. Now it starts at a really fast rate and then it simply slows down. Remember, the function is always increasing. We're always adding water. So this could either look like this or it could look like this, right? It's always increasing. But now we just need to look at the rate. If it's starting at a really fast rate and then it slows down, what does that tell you? If it's slowing down, that means the rate is decreasing, right? Now with a decreasing rate, it means that we're dealing with a concavity that's downwards, which is simply option C. That's it. See how simple it is? Just look at it. We're always adding water, so that means the function is increasing. So it could look like this or like this. Now, as we add water, is the container being filled at a faster rate, or at a slower rate? Well, it's obviously being filled at a slower rate because it's getting more, I would say, wider as we move upwards. So the rate is decreasing. Now, last but not least, question number 20. A car is traveling on a straight road. A graph of the car's position in miles from starting position at time equal to 0 hours on a particular day is shown. Which of the following is true about the car's position for the following? Well, the rate of change of the car's position is increasing until about t equal to 1.25, when the position begins to increase at a constant rate, okay, which is in fact correct. Maybe, wait, no. So it is increasing. The rate of change is increasing, right? It's concave up. That's correct. And then after 1.25, the position begins to increase at a constant rate. This is a constant rate, right? It's a straight line. So yeah, it is option A. What about B? The rate of change is increasing until about time t equal to 1.25. After this time, the position is constant. They're saying the position is constant. No, the rate is constant. It's not that the position is constant. The position is changing. The position at this point was 90, and then at this point it was 110, correct? The position is changing. What about C? The rate of the change of the car's position is increasing at an increasing rate during the entire time interval? No. Do I see a function that just looks like this? C is out. What about D? They're saying that it's increasing at a constant rate. Do I see just a straight line going on? That is also not the case. D is out. So it is option A. And yeah, that is pretty much it for these two videos. And stay tuned. I will hopefully upload 2 other videos probably by tonight or tomorrow morning. Okay, thank you. Bye-bye.